Today we are going to see about the data link layer protocol, Go Back N ARQ. ARQ stands for Automatic Repeat Request. So when the frame is not properly received in the receiver side, the sender has to retransmit the data again. So the sender will keep the data safe without deleting until it gets an acknowledgement. So data link layer in flow control, we have stop and wait protocol and sliding window protocol. Stop and wait we have seen already, that is we send only one frame at a time, get acknowledgement for that frame individually, and then only the sender will send the next frame. So now it is sliding window protocol. Several frames can be transmitted at the same time. It's called sliding window protocol. So how a sliding window looks like? It is like this. So the frames are numbered from here in this example 0 to 7 and the window size is 7. So the window will shift towards the right side. So we have a sender buffer and the receiver buffer in the receiver side. So receiver also we have a sliding window like this. The window slides towards the right side after sending acknowledgement to the receiver. Sender side sliding window slides towards the right side after getting an acknowledgement from the receiver. So error control and a sliding window ARQ, we have the go back in and selective repeat ARQ. So today's topic is about go back in ARQ. So in go back in ARQ, unlike the stop and wait, cumulative acknowledgement is possible. It's not that after receiving every frame, we need not get an acknowledgement. So in this example, the frame size should be in go back N ARQ. Frame size should be, window size should be SL minus SF plus 1. SL is the, so in our window, we have 0, 1, 2, 3. Again the numbers are repeated, so it is 0 again. 1, 2, like that the frame goes on. We have a window like this. Fine. So the window, the first element is SF. First element is denoted by a variable SF. The last element is denoted by a variable SL. The frame currently being transmitted is represented by variable S. So the window size length must be SL minus SF plus 1. So here it is 2 minus 0, 2 plus 1. So the window size is now 3. The window size is not a variable one, it is fixed throughout. So now here the window size is 3, SF the starting variable. In the window, the first element is represented by SF, the last element is represented by SL, and frame currently being transmitted is S. So frame 0 is transmitted. In go back N ARQ, the receiver window size is 1 only. So the receiver is expecting one particular frame only. So here R is equal to 0. The receiver size variable R points to 0. Frame 0 is transmitted and received in the receiver side. Next, frame 1 is transmitted. SF and SL are the same. S shifts to frame 1. Now the frame currently being transmitted is frame 1 transmitted. R is equal to 1 and frame 1 is received. Cumulative acknowledgement is possible. So the receiver sends an ACK2, meaning till frame 1, the number near the acknowledgement tells the frame next to be transmitted by the sender. So till frame 1, this ACK2 means till frame 1 I have received properly. Next frame you need to transmit to me is frame 2. So now after receiving an acknowledgement, the sender side sliding window slides towards the right side. Till one frame we have received the acknowledgement. So the window slides to S is equal to 2. Now SF is 2, SL is 0 and the control variable S which points to the currently transmitted frame is 2. Now frame 2 is transmitted, frame 2 is received and we get an ACK3, meaning frame 2 is successfully received by the receiver. Now the window slides towards the right side again. And then S is equal to 3, frame 3 is transmitted and frame 3 is received. This is the normal operation in go back in ARQ. When a frame is lost, what happens? Frame 0 here in this example is successfully transmitted and received. Frame 1 is successfully transmitted and received. So we get an ACK2 meaning till 1 is successfully received. So the window slides. Now S is equal to 2. Frame 2 is transmitted but it is lost. So we have a timeout time. Timeout time is twice the time taken for propagation time, meaning the time taken for the data to reach the transmitter and getting back an acknowledgement. Twice the time is the timeout time that can be set by the user. So after the timeout time, the sender is again sending the frame 2 itself. By the time it has sent frame 3 also. S becomes equal to 3 since cumulative acknowledgement is possible. It need not wait for an acknowledgement. S shifts to 3, frame 3 is transmitted. But R is expecting frame 2 only. The window size is 1 only. R is expecting 2 only. So it correctly discards the frame 3. Then frame 2, the timeout has reached. So frame 2 is transmitted, retransmitted from the sender again, received. It sends an ACK3 and then shifts towards the right side, the window. And then now S is equal to 3, frame 3 transmitted and frame 3 received. So now when a acknowledgement lost frame, when a frame is lost, what happens is after the timeout period, the frame is resent. Till acknowledgement for that frame is received, the window does not slide. So obviously the data correctly goes to the receiver side. And go back in sender window size and receiver window size. The window size must be less than 2 power m. So here the window size when it is less than 2 power m, which means here 3, 0 to 3 are the frames numbered. So next frame will be again 0 to 3, right? So less than 2 power m. 2 power m is 2 power 1. So let's 2 power 2 is 4. So less than 4, so 3. The window size is 3 here. Here we can see the window size is equal to 2 power m, 2 power 2, 4. So now frame 0 transmitted, acknowledgement lost, received and acknowledgement lost. Frame S is equal to 1, frame 1 transmitted, received but acknowledgement lost. Frame 2 transmitted, received but acknowledgement lost. Again the timeout period has come. So frame 0 is retransmitted but 3 is expected here. So this frame 0 which is retransmitted is correctly discarded. Then the system finds where the problem is and corrects the problem. When the window size is less than 2 power m. When the window size is exactly equal to 2 power m, here window size is 4. Frame 0 transmitted and acknowledgement lost but received here. Frame 1 received, 2 received, 3 received. Everywhere the acknowledgement is lost. Timeout period has come. So S again becomes equal to 0. Frame 0 is retransmitted but it erroneously accepts that frame 0 in the next 0th frame in the receiver side. Which means these 0 to 3 frames are received already but again duplicacy happens here. So the again 0 to 3 again gets accumulated in the receiver which is not required. So it's always recommended in Go Back N ARQ to have a window size of less than 2 power m. So in Go Back N ARQ, the last frame and what the window size should be. Thank you.